I sell shout-outs, just like they do on Instagram. Okay. What? I just designed another one I could show you here in a second. I'm going to start getting some of them for myself. Okay. Stay. Focus. Okay, now, to answer your question about this, what we need to do is look at these terms right here and then go back and look at our definition. Are they talking about sine or cosine? So when I go back up here and I look at the cosine, you notice that it starts out cosine, cosine. Whereas the sine of the sum or difference starts out sine, cosine. So when I looked at letter A, I knew that it went with this one. So my next question is, now that I've made that decision, what are we going to do with the 22 and the 13? Are we going to be adding or are we going to be subtracting? And according to what we have talked about or showed you in the notes, sine keeps the what? Sine keeps the same sign. Remember that. Sine keeps the same sign. Cosine is the one that switches. So if this is a plus, so will this one be. So the answer to my question is sine 35, which is what we showed in the notes. You're going back to the pattern and looking, does it match this one or does it match this one? The second part, well, this part right here matches that right there. Okay. Now, if you're asking me to actually substitute numbers in for sine 22, cosine 13, cosine 22, sine 13, we did more of that kind of thing back in example 1. They're basically handing me this side of the equation and asking me to go backwards to the other side. So they're giving me the expanded form and they want me to put it into a condensed form. Boy, that looks confusing. Okay, the chit-chat needs to end. Okay, now, I know on letter B, because we can't afford it, I know on letter B, every math teacher in the universe wants you to be able to add or subtract fractions. Okay, but I will let you change them to degrees. All right. So pi over 3. How many degrees is that? That's 60, right? How about the pi over 4? What? 45 degrees. Okay, yeah, folks, the unit circle's not going away. We do need to know radians and degrees. We need to know sines and cosines, that kind of stuff. It'll never leave you, ever. Yeah, that's fine. So we're basically looking at cosine 60, sine, or no, sorry, my bad, I can't copy. Cosine 45 plus sine 60, sine 45. Is this matching the sine formula or the cosine formula? It's matching the cosine formula. So we know that this expanded form came from a cosine. Oops, sorry. What are we going to do with those two angles? Well, the cosine formula says that we change the sign. I know. That's rough in a college class. Cosine 15 is the answer to that question. No, I'm not asking you to come up with the value of the cosine of 15. That's a different question. That's more like example 1. This question is asking you to simplify it, put it together. All right. Question C. Does this look like a sine or a cosine? Looks like a cosine. But wait a second. Okay, look here. See how the terms are? Let's go back here and look at this one. Now, this does look a little different, doesn't it? What if we factored out a -1? What if we factored out a -1? What would happen to that? You would end up switching these. Wouldn't you have cosine x, cosine 2x? That would be a positive one, wouldn't it? Minus sine x, sine 2x. Now, why did I do that little trick? Is it easier to tell now whether this is a sine or a cosine? Going back and looking at my notes, does it match that one? Or does it match this one? Well, now it looks like this one, doesn't it? So we know this is based on a cosine. All right, so let's just focus our attention here. Cosine, there's an x and there's a 2x. But what sign goes in the middle? Ah, yeah, because it switches. And what is x plus 2x? 3x. There's only one problem with my answer. Can you tell me what's wrong with my answer? I forgot the negative. That's right, folks. Well, okay. So the trick that they're using is this. You know, back in Algebra 2, they would do things like this. They would write it like 3 minus x. Now, 3 minus x is not the same thing as x minus 3. So the trick there, we could write negative x plus 3, and if you factor out a -1, you switch the signs. That's kind of the trick that they're using from Algebra 2. By pulling out that -1, you are flipping them, which made them look an awful lot like the cosine. Any more questions on these before we move to the next example? Yes. The sine equation, this one right here. Let me erase it so it's a little bit nicer looking. Nope, that's on your formula sheet. Yeah, your cosine sum formulas and sine sum formulas, and then tangent sum formulas and difference formulas are on your formula sheet. Does that help? Okay. Okay, folks, if you get a problem like this and you look at your formula sheet and you see the identity on your formula sheet, don't you dare tell me, oh, hey, I'm done. It's on my formula sheet. This is a proof. So you have to prove it. Remember, I replaced the equal signs with arrows, so you know you have to start with the left and work to the right. So if we're using the sine formula for this, that would be It's sine x cosine pi plus cosine x sine pi. Is it supposed to be a plus or a minus in between? Is it supposed to be a plus or a minus in between? Sine keeps the same sign. As long as you remember sine keeps the same sign, the other one has to be the opposite. Okay. Do you know where pi is on the unit circle? What, Mr. Shoutout Amstutz?
The left side.
The left side, thank you very much. We got pi over here. Pi on the left. What's that coordinate? What is the coordinate right there on the left side? Come on, it's 1 unit to the left of the origin. What's 1 unit to the left of the origin? -1, comma, 0. You might want to use that information. I think you need to substitute something there and something right here. Please show me what you get. Yes, show me. Tell me that you're substituting -1. You are correct. All right, and then what are you going to put in your cosine? What you said? You are correct. I said sine. You told me this one, and you were correct, so I asked this one, and you told me that. Sine x times -1. Correct. Sine x times -1. Wait a second. We don't know what x is, so you can't replace anything for that. Sine x times -1 plus cosine x times 0. Yes? Now, simplify that. I like it. I am really hoping that you replaced that with -1. And I'm really hoping that you replaced this with 0. And yes, you need to show the steps. I understand, folks, that your very next move is to do what with this term? You're going to get rid of it, right? You know that multiplication by 0 is going to destroy that term. So what are we left with? Negative sine x. Folks, that's exactly what we were supposed to be left with, remember? In these proofs, they show us exactly what we're supposed to end up with. Okay. So now we're using a cosine formula, right? Cosine, cosine, sine, sine. All I'm doing is follow the pattern, right? Cosine, cosine, sine, sine. And what goes in the middle? Ah, the minus. The opposite, right? All right. And now we need to replace these two things. Where is 3 pi over 2 on the circle? It's at the bottom, isn't it? And what is that coordinate down there? 0, comma, -1. That's the coordinate at the bottom. You might want to use that information. 1 unit below the origin. Learning. No. So what'd you put in the place of cosine 3 pi over 2? 0. So we have cosine x times 0 minus sine x times what? Times -1, right? And so what happens to this one over here? Cancels out, right? And what happens, what do you have right here? Positive sine x. Which is exactly what you were supposed to get. Okay. I don't need you to write this stuff down here. You already know that tangent is sine over cosine, right? Okay? So I just want you to follow through the logic with me. This is not something you absolutely have to write down. We'll show you the simplified version here in a minute. Okay? And you know that you could substitute something for the top, right? We could substitute something there. We could also substitute something there, and that's what they show me here. I mean, that's a lot of ugliness, right? Now, we can try to simplify this, and in fact, they did simplify that, okay, down below. That's the one that we really need to understand, the simplified version. Now, stay with me. What in the world would you be dividing by to turn this into a positive 1? What would you divide the top equation by in order to get a 1 down there in that bottom left? What are we dividing this by? I don't know. I couldn't hear it. What'd you say? Nope. Good try. What can we divide the blue circled term by in order to turn it into a positive 1? Is the exact same thing. Now, I'm going to write it out for you, but I'm not expecting you to write this out, nor am I expecting you to prove this. I just want you to understand how in the world they simplified this. So they multiplied the top and the bottom. Why? What in the world is going on there? I don't know. I'm lost on that one. Multiplying the top and bottom by that nasty thing. When you do that, and you multiply it times this, and you multiply it times this, you get this numerator. And when you multiply this and this, you get that denominator. We obviously need to focus our attention on the simplified version. That is the one I need you to focus your attention on. Now, since sine is in the top and cosine is in the bottom, maybe I should back up. Do you notice that the sine stayed the same on the top, but the sine changed on the bottom? The sine stayed the same on the top, but it changed on the bottom. That has everything to do with sine being in the numerator and cosine being in the denominator. That's really one of the most important things you need to know about that formula, is just paying attention to the fact that the sine stays the same on the top and flips on the bottom. Now, I'm going to change this question, because the only way you can do this question is to take the tangent of 3 pi over 2. Can you tell me what the tangent of 3 pi over 2 is? Nope. Undefined. If we did this problem the way they have it written, we would have an undefined value. And the only way you can actually do the question they're asking you is to go back to the unsimplified form that has sines and cosines everywhere. I am not interested in you going backwards to that form. I want to know if you could use the simplified version. So I'm going to alter the question. I'm going to change this to pi. And that means we have no idea what it's going to equal. So we're doing tangent theta minus pi. So if I follow what they have, I would have tangent theta plus tangent pi over 1. Oh, wait a sec. Did I do something wrong? Did you catch my mistake? Where's my mistake so far? Right where? Oh, right there. The sine stays the same on the top. Okay. But it changes on the bottom. Okay, simplify it. need to substitute in something for tangent phi. Now, maybe something cancels out. Maybe we'll find out here in a minute. But we need to know on that unit circle that phi is sitting over here on the left. What is the slope of that line? That is going to we need to substitute that. It is. It is. That's the number you should be sticking in there for tangent phi. What is the slope at phi? Slope of phi. Talking about a unit circle. You know, the pi's over here on the left side. So what is the slope of that line right there? 0. You better be substituted in. I see a tangent phi there that I can substitute for, and a tangent phi there that I should substitute for. Do you know what the tangent phi is? We need that slope. So on that circle, we know we're over here at pi. What's the slope of that line? You said it. So we're going to substitute that in. Okay. Can I just say?
Yeah. Yeah, let's go.
Yeah, and what is anything you I want is
He gets so defensive.
The tangent of pi. What did you guys get for the tangent of pi? The slope of that line is 0. So that fact has to be used here and here. So we have the tangent of theta minus 0 over 1 plus tangent theta times 0. Okay? Now, what happens to this thing that I'm circling in the green? Gone. The numerator just simplifies to tangent theta, and the only thing you have left in the bottom is a 1. So those of you who made the conclusion tangent theta are correct. Over 1 doesn't matter, right? That's still okay. You will get laughed at parties, but it is still... the red pen of death cannot take points away if you put tangent theta over pi, or tangent theta over 1. Oh my goodness. Question 1 on the homework. I've listed out the homework questions you need to work on. No, you will not get them all done this weekend. Okay? We will spend Monday answering more homework questions. Do as many of the ones that are listed as possible. But I don't think you'll get through them all. You can look on the calendar. I've got it listed on the calendar for you. So let me get my writing tool for this up and running. It is 5.3. Yep. That's where we're at. Oh, and I better do that. So let's do question 1. Sine of 15 degrees. Use a sum or difference identity to find an exact value. Now, you are either going to use a sum or you're going to use a difference. And you're going to use the nice numbers. The 30s, the 45s, the 60s, maybe a 90. Do I care if you go to 150 and 135? No, I don't care. But I think you might find it easier if you stick to smaller angle measurements. However, sometimes you do need to use those other ones. That's fine. That shouldn't be an issue. Now, can you think of a way to come up with 15 degrees from either a sum or a difference using those common angle measurements? 45 and 30, right? And what would you do with them? Add or subtract? Subtract. So, the first conclusion, now what if somebody next to you said, oh, I wanted to use 60 and 45. Would that work too? Sure it would. There's nothing wrong with that. Sometimes there are multiple options here. So sine 45 minus 30. So I'm going to have to go to my sine formula. And which one? What is that? That's sine 45 cosine 30 cosine 45 sine 30. What goes in the middle? What goes in the middle? Sine keeps the same sign. So let's see here. Let me scroll that so you see more blank space. Let's see. Unit circle. Ooh, that's not too bad. 45 is sitting right here. What is the sine value for 45? That's a y value, folks. Nice try. It's not as high as that one. Radical 3 over 2 would be up a little bit higher. Radical 2 over 2. I know, if I had a nicer circle, it'd be easier to tell. Okay? 30 degrees is over here. How about that cosine? Man, that's pretty close to the edge of the circle. That's positive radical 3 over 2. Yes. Cosine 45. Cosine, that's the x value at 45. Radical 2 over 2. Man, the chit chat is destroying our momentum. Sine 30. 1/2. This is not stuff you guys can afford to talk over me for. And what do you get when you multiply those two together? Yep. And what do you get when you multiply those two together? Do you think I'm okay with that answer?
Heck no.
Well, you would be wrong. I'm okay with that answer. Now, if it bothers you and you would like to make it one single fraction like this, go for it. And if you're practicing, I can open up Math Excels for you if you want to practice. That's not required. But this is what Math Excel would expect. I don't need it, but you know, they do. Either one of those is fine by me for that question. Any questions on that so far? All right. Let's jump down to number 7. What are you going to do with 5 pi over 12? What are you going to do with 5 pi over 12? Do you really want to try to come up with fractional values of pi that add or subtract together to give you that? What should we do with it? Change it 2 degrees. I taught you how to do that. What would you multiply by? Pi over 180? Nope, because the pi's wouldn't cancel. Yeah, 180 over pi. So, many degrees we have. You can even use a calculator if you don't know how to divide 12 into 180. That doesn't come quickly to you. You can use a machine. Right? I mean, 12 goes into 18 ones, 6 of those. That would be 12 goes into 65 times. But if you don't know that, then grab a machine. Okay. Monday's the 9th. How many degrees are we talking about? 75 degrees. Thank you. So this question is the tangent of 75 degrees. What combo are you going to use to come up with 75 degrees? You can use a sum or a difference. Any thoughts? Got to use 30s and 45s and 60s? What do you want? 45 plus 30, right? So we're going to do tangent of 45 plus 30. So yes, we're going to the tangent formula. And the tangent formula was tangent 45 plus tangent 30. Is it plus on the top? Okay, it is because it keeps the same sign on top, but changes the sign on the bottom. Over 1 minus tangent 45, tangent 30. We need to figure, yes, we are multiplying them according to the formula. Okay, we need to know the tangent of 45 degrees. What is the tangent of 40? Boy, that's a bad circle. Okay, what is the tangent of 45 degrees? That's a 1, right? So we're going to substitute that with a 1. What's the tangent of 30 degrees? The one more shallow than that. Folks, the unit circle isn't going away, folks. It's radical 3 over what? It's not 2. That sounds like an x value or a y value. It's over 3. And on the bottom, we'll have 1 minus 1 times radical 3 over 3. We're just substituting in the exact same numbers we had on the top. Now, I'm not happy with that answer, but I will show you one thing to do to make it a little bit easier on the eyes. What would you multiply the top and the bottom by to get rid of the fractions? Let's not go down the conjugate road here, okay? I do know that we could multiply by conjugates. We could rationalize the denominator. We could get all crazy with this. We don't want to. I just want to get rid of the fractions. Let's multiply by 3. Okay, if we multiply this by 3, this will be the last thing we do today, but so walk through with me before we end. What's 3 times 1? 3. 3 times radical 3 over 3. Plus radical 3. Okay, and if I do the same thing on the bottom, I've got 3 times 1, which is 3. And 3 times that is minus radical 3. I'm okay with this answer right here. No, I don't need to rationalize anything. I don't need to find conjugates and waste my time. Okay? Hold on, let me get this stopped.